Welcome to Crashcast Java, where we dive deep into Java concepts and make them accessible to everyone. I'm Victor, and today we're joined by our expert co-host, Sheila. We'll be exploring an intriguing topic, performance profiling, with a focus on comparing the fork, join framework and traditional multithreading in Java.
Thanks, Victor. I'm excited to break down this complex topic for our listeners. Before we dive in, let's start with some basics. Victor, could you give us a quick overview of what performance profiling means in the context of Java programming?
Certainly, Sheila. Performance profiling is like being a detective for your code. It's the process of analyzing your Java program to understand how it behaves, where it spends most of its time, and identifying potential bottlenecks. Think of it as taking your code to a health checkup to see where it might need some optimization.
That's a great analogy, Victor. Now, let's talk about two approaches to handling concurrent tasks in Java: the fork-join framework and traditional multithreading. Victor, could you explain what the fork-join framework is?
Sure thing, Sheila. The fork-join framework, introduced in Java 7, is like a team of efficient workers. Imagine you have a big task, like sorting a massive pile of books. The fork-join framework would split this task into smaller subtasks. That's the fork part. Have different workers tackle these subtasks simultaneously and then combine the results. That's the join part. It's particularly good at handling recursive divide and conquer algorithms.
Excellent explanation, Victor. And how does this differ from traditional multithreading in Java?
Traditional multithreading is more like assigning different tasks to different workers from the start. Each worker, or thread, is responsible for a specific job, and they all work independently. It's great for tasks that can be clearly separated, like having one thread handle user input while another processes data in the background.
I see. So when would a developer choose one approach over the other?
Great question, Sheila. The fork-join framework shines when you have a large task that can be broken down into similar, smaller tasks. For example, it's excellent for processing large datasets, like analyzing millions of log entries. Traditional multithreading, on the other hand, is often better for diverse, independent tasks, like in a typical desktop application, where you might have one thread for the UI and another for background operations.
That makes sense. Now let's talk about performance profiling these two approaches. What tools would you recommend for Java developers to profile their concurrent code?
There are several great tools out there, Sheila. Java's built-in Visual VM is a good starting point. It provides CPU and memory profiling, which can help identify hotspots in your code. For more advanced profiling, tools like YourKit or JProfiler offer detailed insights into thread behavior and performance. These tools can help you visualize how your threads or fork-join tasks are behaving and where they might be bottlenecking.
That's helpful, Victor. Could you walk us through a scenario where performance profiling might reveal differences between fork-join and traditional multithreading?
Absolutely, Sheila. Imagine we're developing a photo editing application that needs to apply a filter to thousands of images. If we use traditional multithreading, we might create a fixed number of threads, each processing a subset of images. With fork-join, we'd create a task that recursively splits the work until we reach a manageable chunk size.
And how might profiling help in this scenario?
Great question. Profiling could reveal that with traditional multithreading, some threads finish early and sit idle while others are still working. This imbalance can lead to underutilization of resources. In contrast, profiling the fork-join version might show better CPU utilization because its work-stealing algorithm allows idle threads to take work from busy ones, leading to more efficient processing.
That's fascinating, Victor. It sounds like the choice between fork-join and traditional multithreading can have a significant impact on performance. Are there any common pitfalls developers should be aware of when working with these approaches?
Absolutely, Sheila. One common pitfall with fork-join is creating tasks that are too small, which can lead to excessive overhead from task creation and management. On the flip side, with traditional multithreading, developers might create too many threads, leading to context switching overhead. Profiling can help identify these issues by showing the time spent on task management versus actual work.
Those are great points, Victor. As we wrap up, Could you list a few advanced topics that our listeners might want to explore further to deepen their understanding of performance profiling and concurrency in Java?
Certainly, Sheila. For those wanting to dive deeper, I'd recommend exploring these 3 topics. First, the internals of the fork-join framework and its work-stealing algorithm. Second, advanced thread synchronization techniques and their performance implications. And third, Java memory model and its impact on concurrent programming and performance.
Thank you, Victor. Those sound like excellent areas for further study. To our listeners, we hope this episode has given you a solid understanding of performance profiling, fork join, and multithreading in Java. Remember, the key to mastering these concepts is practice and experimentation with real-world scenarios.
Absolutely, Sheila. And don't forget to use profiling tools to gain insights into your code's performance. They're invaluable for optimizing your Java applications. Thanks for tuning in to Crashcast Java. If you found this helpful, please subscribe and join us for more deep dives into Java concepts. Until next time, happy coding.